In this video, I will explain you very important two concepts from Earth as a magnet, that is declination and dip at a point. Now, in the previous video, we have learned about the magnetic north and geographic north. So, geographic north is the topmost position. So, we have the axis of rotation of Earth. Now, the top position, the point comes in the north is nothing but north, geographic north in that axis. Now extremely downward position is nothing but geographic south. So this is geographic north and geographic south. That is based on the axis of rotation of Earth. Now we know that magnetic north is certain distance away from geographic north. So that is at this position, and here magnetic south is at this position. Now when we have connected these two lines and these two lines, we have seen an angle of 11.3 degree in the previous case. Now here in this case, first we will learn declination. Now what is declination? Let's say a person from here, let's say from here, this part of the Earth, he has to calculate the angle of declination. So declination is nothing but, declination at a point is the angle between geographic meridian and magnetic meridian at that point. First you should know what is meridian. Now this is the person, right? This person will look towards his geographic north. So this is the geographic north, right? This one is the geographic north, this is magnetic north. Now in that direction we will cut the Earth. So what we will get? We will get two hemispheres, one this one and another one this one. The total thing is Earth, say for example. Okay, so my circle is not perfect here. So he has seen geographic north here and geographic south here, and he is also looking towards the magnetic north. So magnetic north he has seen here, and connecting the magnetic south, we are cutting the Earth in this way. Now this plane is called as geographic meridian. What is geographic meridian? A plane that cuts the Earth in which direction? By passing through 2 points which are geographic north and geographic south. I'll repeat it. So that is a plane, geographic meridian is a plane which is obtained once we cut the Earth passing through geographic north and geographic south at that point. Now magnetic meridian is nothing but it's a plane obtained when we cut the Earth by passing through magnetic north and magnetic south. So for this person, these two are the plane. Now the angle in between these two is simply the declination. Now you will have some confusion here, but I will get that cleared. See, for this person, when he is looking geographic north and magnetic north, he can see these two direction, and we will get the meridians and we can calculate the angle of dip. Now let's say if the person is here, what will be the angle for him if he is looking for, I will keep it here. So this is magnetic north, this is geographic north. Let's say the person is here. Now if he is looking towards geographic north, that is in this direction. Now if he is looking towards magnetic north, that is again this direction. Now these two planes, how do they section Earth? Along the same plane, right? Along the same plane, the section will be made. So what is the declination at that point? Declination is 0. Okay, now at this point, if a person see magnetic north, that is a plane like this. This is geographic meridian. Now if the same person see geographic north, and that will be in this way, and that plane is geographic meridian. Now the angle in between magnetic meridian and geographic meridian is angle of declination at that point. So that is declination. Declination at a point is the angle between geographic meridian and magnetic meridian at that point. I have explained it very clearly. Next thing is angle of dip. Angle of dip is very, very important. Okay, so you can expect numericals from angle of dip. So angle of dip is nothing but on the surface of earth. So I am going to keep geographic north-south axis in this way. So this is north and this one is south, and earth in this way. Okay, so we are near to equator, right? So let's say we are at this point, India is at this point. Now we know that okay. Now we know that the magnetic field that connect north and south will be in this way. And here it will be in this way. Here it will be in this way. Here it will be in this way. Okay. Now for a person here, what is his horizon? Horizon is nothing but horizontal axis. That will be in this way. So let's say the person is here. The horizontal axis is in this way for that person. Now, what is the net direction of magnetic field here? That is the direction of magnetic field line in this way. See, this is the horizon. For a person here, the horizon is in this way and direction of magnetic field is in this way. Now for a person here, horizon is in this way. Now direction of magnetic field is just going through his head. For a person here, say for example, horizon is here, then direction of magnetic field. How to get the direction of magnetic field? At that point, draw the tangent with magnetic field line. So this is the magnetic field at this point. I have drawn a tangent. So this is direction of magnetic field. Now earth, when I am drawing in this way, from here it is coming in this way. So here the magnetic field is in this direction, but our horizontal is in this direction. But at the same person, if he is standing here on the equator, then this is horizon and direction of magnetic field is parallel to this. Have you seen one thing here? The angle in between the net direction of magnetic field and horizontal or horizon has been decreased from 90 to 0 when we are traveling from magnetic north to this direction, equator. Okay, magnetic equator. See, now we know that there is an angle in between the horizon and net magnetic field, and that angle is angle of dip. So angle of dip at a position is the angle between Earth's magnetic field. So let's say this is Earth's magnetic field, and horizon will be always horizontal. So this now we are standing on the surface of Earth, right? So with respect to me, this is the horizontal. Now how to get the value of direction of magnetic field at that point? It's very simple. Just keep a magnetic needle hanging at a point. So what will happen? Instead of, say, if it is going in this way, which means this will happen basically at equator where magnetic field line is parallel. Now when we are going to north, what will happen? The magnet will be in this way because the north will be exactly facing the magnetic north. South will be, so because the magnetic field lines are passing in this direction. Now at the same person, when we are going on the equator, then that will be rotated in this way. On the magnetic north, that will be in this way. So we can get the direction of magnetic field at a point with this principle. Now the angle in between magnetic field B and horizontal at that point is nothing but angle of dip. So angle of dip. Now I can split magnetic field into two directions. We know that I can, so let's say this vector I am going to split into two directions. So this is vertical component, B vertical, and this is B horizontal. Okay, so the same thing when I am copying here, I will get a line in this way. This is B vertical. Now what is cos delta from here? Cos delta and sin dip. What is cos dip? Cos dip is nothing but adjacent by hypotenuse. That is BH divided by B. So this implies BH horizontal component is equal to B into cos dip. Now from here, what is sin dip? Opposite by hypotenuse. So sin dip is equal to BV divided by B. This implies BV is equal to B sin dip. So we got two values. So this is simply horizontal component of magnetic field at a point and vertical component of magnetic field at a point. Let's say we have found out these two values. Now how can we get the value of B? Just square and add. Just square and add. What we will get? We will get B horizontal square plus B vertical square is equal to, what is this? B square cos dip square plus B square sin dip square. So B square is common. Cos square theta plus sin square theta. What it is? 1, right? So this is B square itself. So B square is equal to B horizontal square plus B vertical square. So from this I am rewriting the equation here. B square is equal to B horizontal square plus B vertical square. Now this implies that B at a point is equal to square root of B horizontal square plus B vertical square. What is the definition? Magnetic field at a point on surface of earth is equal to square of horizontal component at that point plus vertical component at that point. So these two concepts are very simple to understand if you know the concept, and very important from this chapter. Declination I will repeat. How will you get the value of declination? Go to a point, just find your magnetic meridian and find your geographic meridian. How to get magnetic meridian? Look towards magnetic north and connect. So make a plane that is passing through magnetic north and magnetic south. So that is magnetic meridian. Now how to get the value? So let's say for me it is in this way. So I am looking towards magnetic north and I see geographic south also. I am cutting through this plane. That is my meridian. Okay. Now how to get my geographic meridian? Look towards geographic north and geographic south. Connecting these two points, we can cut the earth in this way. So I will get geographic meridian. So magnetic meridian and geographic meridian. So these two hands are making an angle. This is angle of declination at that point. Now to get angle of dip, numericals will be based on angle of dip. Angle of dip at a point is with respect to horizontal. How to get the horizontal? Wherever you are standing with respect to the surface of earth, just draw a horizontal line. So with respect to me, this is a horizontal line. This is an horizontal line. Okay. Now here I should keep a magnet in this way to get the value of mag. So this is my horizontal. Now magnet is getting directed in this direction. So this is the direction of magnetic field, and this angle is representing the angle of dip. Okay, so if you know the magnetic field and dip here, so horizontal component and vertical component can be made with B cos theta and B sin theta respectively. This is very important. Make a note of it. Thank you.